Assalamu alaikum guys. So in today's lecture, we are going to do atomic structure. So after a long time, I've been uploading this video. So let's start. So what is an atom? Atom is basically a small particle of an element which contain the same chemical properties as the element and takes part in a chemical reaction. Okay. So this is the definition of atom. So you may note it down. Now, what is like the structure of an atom? Basically, so atom has a nucleus, okay, has a nucleus. Then, wait, let me adjust the thickness. Okay, so now atom has a nucleus. In a nucleus, there are two particles which are proton and neutron. Okay, then after this, outside the nucleus, there are orbital orbits. Okay, or shells, or also known as energy level or principal quantum shell. Okay, so these are all four terminologies used for a shell. Okay, then in that shell there's electron. So let's move on to their charges. So proton is positive, neutron has neutral, it is neutral, it doesn't have charge, and electron is negatively charged. So here these are some points that which you may wrote down. That centrally located nucleus has two types of particles. Okay, and atom is basically electrically neutral species. Okay, because there's same number of electron and same number of proton. Around the nucleus we have shells or orbits. Okay, this is what which I just explained. So basically shell or orbits are represented by n also. Okay, which is the principal quantum number or the number of shell, and can be used to calculate the maximum number of electrons in the principal quantum shell. Like how there is a formula. Okay, uh, which is 2n square. So this n is the number of shells. By this we can like tell that how many electrons are in one cell. Let's suppose this is let's suppose there are two shells. So by this formula, which is we can put that the values instead of n, and we can get that 8 electrons can be adjusted in the shell. Okay, so this is the formula. By this formula, we can tell the number of electrons in the shell. Like if it's the second shell, it will have 8 electrons, or if it's the first shell, it can adjust 2 electrons, or if it's the third shell, it will have 18 electrons. So this is how it's done. Now, here is an example of this formula that how can be used. Like for example, there's one shell, so one is written instead of n, and by this we can say that the 2 electrons are in the first shell. So now let's move on to the structure of an atom. Now, atom is basically comprised of nucleus. Okay, It, okay. So it is comprised of a nucleus. Atom is comprised of a nucleus. Then outside the nucleus there are shells. Now in shells there are subshells. Okay, and subshell consists of orbitals, and in those orbitals electrons are found. Okay, in those orbitals the electrons are found. Now if we look, so there are four types of orbitals. One is s, then it is p and d and f. So four types of orbitals. Okay, but what is an orbital? Orbital is basically a region of space in which the probability of finding an electron is the highest. So approximately 95%. It is the there is the probability of finding electron. Each orbital have can have a maximum of two electrons. Okay, each orbital can have a maximum of two electrons. So how, like, so the structure of I guess the structure of this atom of the subshell is clear to you guys. That shell, that there is a shell, and in that shell there is a subshell. In that subshell there are orbitals, and in those orbitals electrons are there, and maximum of two electrons can be there. Now let's do it with an example. Let's suppose like there is your parent who come to the school, okay, and they are wanting to find you in the school. So how will they find you? The most probable place which you will be, it will be like in the school. Then in the school where you'll be in the classroom. Then the classroom where you'll be on the chair. Then in the chair or the bench which can hold two people, you'll be sitting there, right? So this is how, like, the school is compared to the shell, then the classroom is compared to the subshell, then then the bench is compared to the orbital, okay? Bench is compared to the orbital, and the person or you means you are compared to the electrons. I hope you might get it. So now let's come to the subshells. So the S subshell has one orbital, okay? It has the lowest energy, and it can, the maximum amount of electrons that can be in it are two electrons, okay? Now the P subshell has three orbitals, okay? What are they? Px, Py, and Pz. So as each orbital can have two electrons, so there are three orbitals, they will have six electrons. So maximum electrons that can be in it are six, okay? So this is the maximum. Now there is a subshell which has five orbitals, okay, five d orbitals. Which the names you don't have to remember it, okay? So it isn't like the syllabus, and it, as each can hold two electrons, so five orbitals can hold up to 10 electrons, okay, the max. Now there is this F subshell which has seven electrons, and it has the highest energy, okay? So as each electrons can hold up to two electrons, so it will have, so the seven orbitals will maximally like can hold up to 14 electrons. Okay, now let's come to ions. What are ions? Ions are basically of two types, cations and anions. Cations are positively charged, okay? So how are they positively charged? That when number of proton is more than the number of electrons, okay? So when the number of proton is more than the number of electrons, it will have a cation. It will have a positively charged ion, okay? Let's suppose a ion, okay? In this ion, what is the configuration? It is like a 11 proton, okay, and 10 electrons. So it has more protons than electrons, hence it will be a cation. Now let's move on to anion. Anion are negatively charged ions, okay? How are they negatively charged? That when the, like in this, the proton number is more, in the anion electron are more, okay, than the proton. And we can take oxygen, okay, the ion of oxygen, that okay, so as we can see in the symbol, it means that it has two more electrons. Now there's an important thing, that the proton number never changes. It always, the negative charge that differs, okay? So basically it means that always the electrons are added or subtracted Okay, the proton number are no never be are never changed. Now let's move on to isotopes. What are isotopes? Isotopes are atoms of the same element having same proton number, same number of electrons, but different number of neutrons. Okay, what are isotopes? Isotopes are atoms of the same element having same number of protons, same number of electrons, but different number of neutrons. What are some? So basically, what does this mean? It means that proton number and the electron number are the same and the neutron are different. So basically, its physical properties, its chemical properties are not changed, but it can be changed. Okay. Now there are some notes that if proton number changes, element becomes different. Okay. If number of electron changes, element becomes ions. If number of neutron changes, atom becomes isotope. Okay. So what are some examples of isotope? There are three isotopes of hydrogen. Okay, protium, deuterium, and tritium. And there are also isotopes of carbon, fluorine, bromine, and so much. Okay, and this carbon 14 is radioactive. Fluorine has also two isotopes. Bromine has two isotopes. Like this, there's the isotope of chlorine also. So there are many isotopes. So that's it for today, guys. I hope you understand. Now let's do the summary until now which we have done it. So until now we have done the atom, the atomic structure, okay, some properties, then the principal quantum number, then the formula that how many electrons can be adjusted in the shell. Then we have done that shell have subshell and subshell have orbitals, and those orbitals electrons or can be located. So there's approximately of 95% chance that electrons will be there. Then there is the point that each orbital can hold up to two electrons, the maximum. Then there are four types of subshells: S, P, D, F, and S subshell have one orbital, P subshell have three orbitals, D subshell have five orbitals, and F subshell have seven orbitals, in which S is the lowest energy and F has the highest energy. Okay, so and then we have done the ions, cations, and anions, and with it we have done the isotope examples, and that's it. So in the next lecture we will do Hund's rule, the electronic configuration, and Aufbau's rules. So that's it for today, guys. Allah Hafiz.